novel thing of streaming the building of this amplifier. So I figured I'd continue on with testing it, doing the sort of tidying up of wiring and solder joints and so on. And so that's what we'll be doing today. And, maybe I'll get some people who aren't complete night owls on the East Coast by actually getting going in the afternoon here on the West Coast. Of course, couldn't do it yesterday because I was leading a field trip for my class in the field. All right, I gotta be mindful of this light of mine. Try to keep it out of the shot. Anyway, give me a sec and I will get the chat up on my laptop and we will get started. And what the frick is poking me in my butt? Random amplifier and soldering detritus. Okay, well. Yes. It's like that. Well, let's give you a little something to listen to while I'm getting this going. I took a field trip yesterday. It's work, but it was kind of fun. As long as nothing goes wrong on one of these field trips, and actually, especially when the field trips when the class is relatively small, and so everybody can really take an active hand in collecting data, have a voice in the field. It's easy to get if you're part of a large group. It's and you're in difficult physical conditions. It's not always easy to feel like you're really a part of it. And I think having a relatively small number of students in that kind of situation in which we were actively collecting data in a stream, that I think that just goes better. And so I've only, whereas last year I had maybe almost 20 students for this class, taking that many students into the field is challenging. This year I had 5, or have 5, and they let me teach it anyway, which is awesome. And the enrollment kind of oscillates. Maybe I'm kidding myself, but I feel like the enrollment kind of oscillates between large and small. You get a small class year, and the people who were in it talk about how great it was, and so then next year a lot of people enroll, and with a big class it's not so great, and a lot of people don't feel like it was awesome. Maybe a few do, but the number of negative experiences or so experiences maybe is larger. So the next year not so many people sign up. And it goes back and forth like that. Or it's just random, because it's always small numbers in the first place. I mean, 20 is not a big number, statistically speaking. All right, sorry, I'm getting here. All right. Channel. Yeah, so looks like it's just me so far, so I'm just talking to myself or to any of you who might be watching this later, because that's a thing too. Anyway, like I said, I will be working on the build of this amp, and by working on the build I mean last night the last component to be soldered into its place was this filter cap for the regulated supply for the right channel. uh, input and phase splitter stage as. So uh, now I need to test it. Before I actually test it, I will I want to go through and maybe get things into better positions and so on. I got a great suggestion in a comment from David Clayton. I should have thought of this, but I just, it's not something I've ever done. He said that if I use a heat gun, obviously at modest temperature, if I use a heat gun, it'll be relatively easy for me to get the wires to lay down where I want them to. So that might be among the first things I do. Uh, I might touch up some solder joints before I do that, though. So actually, I better go ahead and turn on that iron. And yeah. So, and while I think about it, I'm gonna share this link, the link to this live stream to Facebook. Sorry, I mean, I've been getting a few people watching, and that's awesome. It'd be nice to get a few more. Ways. Sorry for the interruption in the dialogue. Just trying to get this going and promote it just a little bit. Send notifications, check your Facebook there and approve the login. Really? Can I even do that? Yeah, I guess I can. I hope that didn't restart the stream. Looks like it didn't. Okay. Looks like it flipped the orientation for a second. No big deal. Blah 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 blah. Yeah. So anyway, we went out into the field. It was cool. I don't know. But it's always good when I've been taking people into, places that are inherently kind of dangerous just because they are so remote and there's so many obstacles. Go feed. I don't know what you. All right. So I don't know if all that. Sorry, I was trying to post. Never mind. Never mind. It doesn't matter. Let's try something different. Anyway, yeah, so I took them to this very remote spot. You have to, to get there, we have to park at a locked gate and walk down a road for a ways, and then walk from the road to the creek, and then so it's not super difficult. It's just there's it's not the kind of place where a lot of people it's not a place that a lot of people know about, and those that do know about it, I know most of them. And so it's a cool spot. It's an old growth. It's a stream through old growth forest, which doesn't mean all the trees are huge. It just means some of them are. And it's the kind of place most people don't ever see anymore because there aren't that many spots of true old growth left in the Oregon Coast Range. And because of that, even people who are interested in streams, perhaps anglers even, aren't really used to seeing these streams in their natural condition. And the fact of at least some very large trees, say 2 meters in diameter, that can fall into a stream that's only maybe 10 meters wide, and has maybe a meter of bed relief. That's a significant seeing something like that when you haven't seen it before is a new thing for people. I know for me it was. I had worked in a Coast Range stream for a while, a field season really, before I saw one in old growth forest. And I was like, wow, I've been trying to numerically model this system, and I've made certain assumptions based on my observations of streams that were not in old growth forests. And those assumptions might not be valid, or at least I've got to revisit some of those assumptions based on seeing it the way it is naturally. Anyway, our next field trip will be to a stream that was restored about 20 years ago. So-called restored, I will say. It was rebuilt. And the job of the students in sorry, just noticing that the title of this video stream got super garbled. Let me correct that. Jeez Louise. Or did it? Looks fine. What the hell? Why did it look garbled on my screen? Casino tiding the anyway, blah blah blah. It was fun. It's work, but it's the kind of work that's pretty pleasant, really. And yeah. See, just two of us watching right now. Well, whatever. We'll pick some up. No point in getting discouraged. All right. Okay, let me get to it. The iron is warmed, heated. So my first thing is a lot of these joints I have made, especially on the big lugs. I've made and preserve the easy ability to add new components as I go. It's generally best, I think, to close those loops, to fill those with solder, rather than leave them open like this one and this one. So that's sort of my first order of business. Now it's not always super straightforward to accomplish closing those up because I don't know, you're trying to get surface tension in the liquid solder to bridge the gap, and it doesn't always cooperate, and you're trying to do that without the components themselves may not be, well, they may be held in place by the solder, so when you melt the solder, maybe components start flopping around, and that's not awesome. And so we take that risk in doing what I'm about to do, which is to start adding solder here and try to bridge and close. Oh, and it can be so frustrating because it'll be there for a fraction of a second, and then you take the iron off, and now see, there's the idea. Isn't that much better? So much better. I'm not even watching the stream. Am I alive? No. Sorry, I went away from my own stream for a second. No, there's only one of you, it's only me watching anyway. What the fuck? Come on. Am I alive? There we go. All right, so closing up holes, that's the first order of business. It, if nothing else, it ensures that everything attached, every wire that goes through that hole has a good connection. And I simply need to worry about keeping this light out of the shot as I do this. Some of these are much easier than others. This one's tricky. There. That's not totally closed. Let me get over here. Awesome. That's the idea. Let's do other power supply now. That other one is going to be tough. I don't know if I should even really bother. Well, yeah, I think that's, I don't know, let me just try. Might be more trouble than it's worth. Sometimes it's more trouble than it's worth. I mean, which is, I don't know. What do I not know? I mean that you always want to make sure your solder joints are good. And this is one way to do that. It's not the only way. but it is a way. I'm not gonna, but there is one I can do, I think. Okay. Get these over here. Now there is, or there can be, a risk in trying too hard here. Of course, there's a risk that you overheat components. But the other risk, and it's not so much with these lugs, but with trying to close the holes on the tube sockets, is that solder flows down into and obscures and fouls the place where the tube pin has to go in, and that's a pain to undo. It can be undone, but it's a pain to undo that issue. So and then there's also just, the more I'm fiddling around in here, the more chance that the hot iron is going to contact something and melt it. And so when I give up, it's not just because I lack fortitude. It's prudence. Dear Prudence, won't you come out to play? Sun is out, the sky is blue, it's beautiful, and so are you, dear Prudence. Won't you come out to play? The other, I don't know if it's the one bummer about streaming while I'm working. Can't play music, y'all. So, hey, show up in the chat, keep me company, entertain me. make this a two-way thing, y'all. I know there's only a couple of you, so whatever. Oh, I will mention again, and I'm not going to push it, but I will mention that super chats are a thing. That is where you pay to make your chat post. It's otherwise this isn't probably going to make me any money, which I'm fine with. I'm fine with it. I also see this sort of as a way of giving back to those of you who are loyal or regular or whatever viewers, in that I've been not unable, but I've just not been producing videos in the last few weeks at the kind of pace that I had been previously. And as much as anything, I want to let y'all know I'm still here, I'm fine, I'm doing all right, and give you a reason to tune in and something to watch if you do enjoy watching my videos. Obviously this isn't produced and edited like my normal videos, so there we go. There. Having thoughts. I mentioned last time, so okay, I thought of this because I'm about to come over here and start touching up solder joints, closing the holes, etc. here, but one of these is for these resistors. These are meant to drop the voltage on the 6-volt supply, get it from the relatively elevated value that I measured prior to embarking on this work, which was about 6.9 volts. And that's because we now have higher wall voltage than when this was made. And so these are meant to drop that voltage to more like 6.3 exactly. But I'm not sure I've done it right. So I think before I check that, I want to plug in all of the tubes except for the rectifier to check the heater circuit and make sure that that works as it should, and that those resistors are doing what I intended for them to do. So with that, then now I do need to, this is always tricky. What are the issues here? No, we're good. Yeah, I won't get high voltage because I won't have the rectifier there. All right. So let me also just give this a shake. Get random snipped bits out of there. Oh. Well, I guess I'm going to have to take off the masking tape to get at these sockets. See, the top of the chassis was a grubby old, late 50s, early 60s, steel, probably cadmium plated, stained, pretty nasty looking, really. Want to make it look pretty, so painted it. Put masking tape on the tube sockets. And usually I take that off right away before the paint's set up super all the way. But I kept it on so I wouldn't have to do it again if I needed to touch up the paint job again, because this was remasking from having to touch up the paint job after I put on the chassis mounted resistors here on top. Those are for cathode biasing the power output stage. and in the process of putting those in, after I'd already painted the chassis, the paint got scarred, and so I had to paint it again. You can see I didn't mask everything, so there's a bit of sparkly paint here in here. Yeah. So it's painted from this direction, so it's not perfect, but it's better than a bunch of gouges appearing in the paint job. The tricky bit here is that I don't want to peel up paint off of the chassis when I peel up the tape. And if you peel the tape, if you take off the tape while the paint is still at least slightly wet, or even if it's fully wet, you don't run as much risk of peeling up the paint from where you want it when you peel off the tape. I'm gonna use a knife very carefully, just score around here. Of course, I want to be super careful not to mess up the paint job. I'm trying to preserve the paint job. I might destroy the paint job. That would suck. All these things are part of an amplifier build. If you want, especially if you want that amp to be presentable, you know, in the past, when this amp was built, it was not meant to be shown. It was meant to be hidden inside the chassis. But, you know, now with us, those of us who have kind of rediscovered tubes, you know, part of the reason we like them is because we think they sound good. Maybe some tube circuits actually sound better than solid state circuits. That's something we can debate. And I don't actually have a strong position in that debate. I'm not particularly interested in having that debate. I mean, let me restate it. I'm interested in listening to that debate, but I'm not educated enough to have a strong position in it. And I'm fine with admitting that a lot of what I like about tubes is the way they look. And therefore the amplifier needs to be presentable if I'm going to have it out where I can look at it. I think, I don't know, I don't know if tube lovers, I don't think that's a controversial thing these days, that part of the thing we like about tube amps is the way they look. And so, this tricky business becomes part of the build that is important. Makes me nervous, though. Mm. I think the problem is the paint is very thick here, and I just don't want to fuck it up. You know, I just want to like rip it off. But you know, I also don't want to screw up that paint job. Ah. Anybody out there know why input stage, the small tubes and the power tubes have different types of sockets when they're both 9-pin sockets? I don't actually know why that is. It seems to often be the case, but I don't know why. All right, and I'll go ahead and take this tape off too while I'm doing the tape thing. If you hear fan noise, it's my ancient laptop trying to keep up with the stream. It's sad. Sad. All right. Where was I? I was going to put in all of the tubes except for the rectifier so that I can test the heater circuit. See, these are 6 CG7s. They might be original, although this one's Sylvania branded. This one, okay, this one's RCA branded. Um, seems like the originals would have been both RCA branded. I don't know though. And why? Because this is an RCA chassis. No, I haven't tested these tubes. Probably should. These are what appear to be new. So I think that means they're new old stock, but these are Soviet era tubes that are the equivalent of EL84s, but are 6P 14P EP. Well, ER. Sorry, so Russian alphabet, the pi is a P, and what looks like a P is an R. Okay. That's dog and people coming and going upstairs, if you can hear the noise. Yes, that was a heavy sigh. Oh, I should put this through the dim bulb tester first. That was a light bulb. probably not the best place for that light bulb, but and I guess nowadays I should be more specific that that was an incandescent light bulb, which is what you want for a dim bulb tester. What are we going to do when we can't get incandescents? I mean, incandescents are kind of hard to come by anymore, so what do we do for our dim bulb testers if we can't find a freaking incandescent bulb? Okay. I meant to have that switch off when I plugged it in, but it's all good. It's not super bright. You know, the thing is these heaters take up a significant amount of current, and so you're in a tube amp, your bulb never gets all that dim like it does with a solid state amp. And don't really. Well, anyway. Just testing for shorts. So we'll turn it off, unplug it, plug it back in to mains to actually test the heater circuit. All right. The heaters are lighting up. That's good. Now check the heater voltage. Let's see what's in frame. You're probably not going to be able to see the display. Let me just see if I need to. Okay, so measure AC voltage. Essentially pick any two heater terminals and see what I've got. That's not awesome. 6.75. so I think the first thing for me to do would be to remove one of those resistors and see if that has any effect. See, my recollection is that when I measured the heater voltage previously, it was 6.9 volts. And so it's possible that putting those resistors in that circuit has had an effect, but not enough of an effect. Now, they're relatively low ohmage, and you can't see them right now. I understand that. But you will recall they were the big sort of sand casted resistors. They're only 1/3 of an ohm each, and I have them 2 in parallel. And so if I remove one, then that will, so in parallel, then I've got 1/6 of an ohm. If I remove one, then I'd be up to 1/3 of an ohm. I could put them in series, and then that would be 2/3 of an ohm. Okay. And so now I just gotta take the tubes back out. And yes, those are toasty. These might be hot. Not bad. Okay. See, the thing is that while I sort of convinced myself that putting the resistors in the place that they are would do the job, I'm not sure about that. And so I want to make sure I'm having some effect at all. So, like I said, the idea would be to remove one. What's the best way to do that? I'll just go ahead and suck the solder off of at least one of those joints. I can just suck the solder off of this joint. Maybe I can just take one of these out of circuit without messing with the other end. Powering on the Hakko FR301. It's a wonderful tool. Hakko, if you're out there, totally willing to be an affiliate. I believe in your products. I don't exclusively use Hakko products. I have a Weller soldering iron. Hakko makes good, Hakko, whatever. Make good soldering irons. The solder sucker, boy, that is shiznit. All right. Well, I appreciate those of you who are watching. Viewership numbers are not astounding. But, you know, I get it. I mean, here in Western Oregon, it's a beautiful day. I would not suppose, would not expect any of my Western Oregon viewers to be sacrificing their beautiful Sunday in order to stay inside and watch me in my basement. But it'd be awesome. Should not have turned off the soldering. Well,
Oh.
Okay. So now we have one 1/3 ohm resistor. And so let's see if I'm right in my recollection that I started out at 6.9 and a sixth of an ohm dropped me to 6.75. That is, I had a 0.15 volt change. Then taking out one resistor should, I think, get me double the voltage drop, 0.3, which take me down to 6.6 volts. It's not all the way to where I would like to be, but is at least an indication that I'm on the right track. And can go from there to figure out, well, maybe I put them both in series, and then that gets me 4 times that original 0.15 volt drop, which is 0.6 volts, which would get me right down to 6.3. Okay, I did that math in my head, y'all. If it was right, I don't trust my ability to do math in my head in front of people, even if they're not actually in the room with me. So let's see. I should brace myself for the possibility that I've been going about this all wrong and that that change will have had no effect. Okay. Yeah, no effect. Going about it all wrong. That sucks. I'll have to look back at some old schematics to see how I've done it in the past. Yeah, for whatever reason, I don't find this sort of modification intuitive at all. At least I know something now. Let's see if I can find an appropriate schematic. I think I did this mod, or at least the intended mod, for the Payco. And it looks like I do actually have a couple of power supply schematics. What? That's not the sort of power supply schematic I was looking for. Crap. It's not a heater supply. It's not. That's a high voltage supply. Try and see if the other one is a heater supply. Yeah, not a heater supply. Crap. Oh. Okay, I have a schematic named heater circuit step down. Yeah, that would be it. Okay. Okay, so in this one, okay, I'm modeling all the heaters as 1.31 ohms. Interesting. All right, I see why this is a problem. Why the way I'm doing it is a problem. Yeah. Okay, I know what to do. So, I might as well see if I can share that schematic with those of you who are watching. Small number as it is. So this is supposed to be all the heaters. And then here's just like 50 and 50 ohms to ground. That part doesn't really do anything. Except reference the center voltage to wherever you want if it's not ground. Anyway, 1/3 of an ohm, 2/3 ohm resistors in parallel in series with the heaters, like so. This is the heater supplies. And right now what I've got is these are over here, and that's not doing jack. So like I said, I don't know why this is just not. It helps to look at the schematic, which is what I should have done in the first place, but I figured I would just wing it and trust Trust myself? I don't know. Whatever. Okay, well, I got it wrong. That's fine. I will get it right now. Yeah, I hope that noise upstairs isn't too loud. Oh, wow. Adam Brown from Rushden, England. Good morning yourself. Morning. Jeez. I don't know what time that means it's there. Probably just I mean, it's like midnight there. Anyway, happy to have you. Thank you for tuning in and letting me know you're out there. It's always cool to get a little feedback. How does this work? Okay, that's the ground tap. It's weird. I'm just not familiar with there being a ground tap on the heater circuit. Anyway, I guess I'll just hook it to ground. Like, as in, duh. Which means I need somewhere to put these. Here's going straight to there. Oh, fuss and bother. And now Pooh began to sing a complaining song. I don't, yeah, I got, those need to stay there. So what I need to do is disconnect one of these wires, one of these heater wires here. Instead, run it to this post. And then go from the other end of the resistors over to here. And this one I need to disconnect and take it straight to ground, which should, have no problem doing because that is a ground lug right there. So I just take this one off here, put it over here. Take one off of here, put it here. Take off this wire altogether, or actually maybe, well, unless it's exactly the right length to go from here back over to here, which of course it won't be. Yeah, Stephen, this is, well, I won't say my own design. It's my own selection of modifications or selection of pieces of design in an RCA amplifier chassis. This would have been in a console back in the day. It's an RS-177A. And so I'm keeping the tube complement, the power transformer, the tube sockets, and almost nothing else other than a few, some lug strips. I've added the choke. I've kept some of the things that were added, like, basically these speaker terminals were added by somebody else. I put in this lug strip thinking I would need it. I would need more spots, but ended up not needing it. So that's why these are empty. Anyway, just to fill you in a little bit. Let's see if that might be exactly the right length. Maybe, probably not. Depends on how I want to get through. Anyway, keep that on reserve in case it proves useful. Now, some reconnection in this heater circuit. I don't know what I was thinking. I just wasn't thinking right when I put this together the first time. And really, that's brilliant. I'm Thank you, Mr. Audio Nut. Appreciate that. Yeah, it's hard work. I mean, look, let's not kid ourselves. It's not a coal mine. It's not working in a coal mine, but it's labor. It is significant labor. And it is, I guess the thing is really it's craftsmanship. It's care in craftsmanship. This is tricky. Foiling all of my efforts to do certain things before others so that this kind of thing wasn't necessary. Trying to close the lug there, not succeeding. Okay, so now wire needs to go from here to here. See if this wire will do the trick. Oh, I'm sorry, y'all. Didn't mean to block your view. Yeah, so yeah, just doing what I said I was doing, but I meant to show you, not block it. If I do that again, you are welcome to say something on the chat. I mean, whether I see the chat before I notice the lights in the view, but I don't know. But please feel free to let me know if something like that happens again. That time was obvious, but times I'm essentially having to sit here with the lamp right next to my head. It's a little awkward, so push it out of my way, and that will push it into your view, and it's not my intent. Okay. Now let's see. Maybe we're cooking with gas now. I don't know if this is the right thing exactly for this amplifier. The Payco, these are the values of resistors that I used on the Payco, but those values are, it has a lot more tubes than this one, so it might be totally off. And we'll see. Trial and error is fine by me at this point. I'm just not in the headspace to try to do all the calculations. I don't know. If this is wrong, then I'll probably actually try to do the calculation, see what this value should be. Anyway. All right. Okay, drum roll. You can see that. So we're down to 5.96, or essentially 6 volts. It's actually low. That's too low. Now let me think about that. I think that makes sense. So fewer tubes drawing less current. Wait, that doesn't make sense. Fewer tubes drawing less. Fewer tubes means less current draw, right? Oh, no, it doesn't make sense. Wait. Yeah, yeah. So fewer. Oh, God. All right. I don't know. I can't figure it out right now. My head's not up to the task. Essentially, it means 1/6 of a volt is too much. Fucking 1/6 of a volt is too much. What do I have? Alright, I gotta do the calculation. God damn it. I'm gonna do this so that y'all can. And when I say do the calculation, I mean I at least gotta simulate this. This is the low tech way to share your screen. Let's see. Say this as. Because currently I do not have 50 ohms here. Anyway, here's how this goes. So, hit run, we get a graph. And I want to do math. So I want the voltage drop across that resistor. What do I have? I've got nodes 2 and 3. So and we want to get an amplitude there. Would this give me an RMS? It just gives me a current. All right. All right, so I want to know what this peak value is. That's 8.8 volts. And I want to know what the RMS of that is. Anybody want to run the numbers for me? I need to multiply by square root of 2. No, divide by square root of 2. I don't have a calculator handy. Surely there's a calculator on this computer. Yeah. Okay, so what is it? It's 8.8 volts. .16. What was it getting? I was getting about that. Wasn't I? God damn it. Should have written it down. Or at least remembered. Sorry, I'm distracted. Let me check the tolerance. Let me check the data sheet for, I don't know, 6CG7, I suppose. .3 volts plus or minus 10%, which is 0.63. So, the 6.7 would have been in spec, but it's it's just nice to have it a bit lower, but 6.16 is well in spec. So that's what I'm getting. So I think I'm good. And I could have just left it undone, but this'll put less stress on the tubes over time. So we're good. I'm gonna call it good. I'm gonna measure it again because make sure what I'm getting is what I seem to recall. what do I call you? True voice of reason. TTVOR. What accessories are you referring to? And good to see you. You were up late, so appreciate you being here. Check that voltage one more time. How does this happen? That was a rhetorical question. What's going on? What's happening here? Okay, that's not what I was remembering. Okay, so 5.9, that's not awesome. You know, it's like about as much to, I was getting 6.75 or whatever without those resistors where they are now. And that's a 0.45 over. What am I getting? Like 0.35 under now. Ugh. It's not right. It's not good. That's too low. Let me monitor it a little bit, see what, let it warm up a bit before I decide to change it. So I mean, it would be fine, but it was kind of fine before too. So it's 0.3 low rather than 0.45 over. Oh boy. So putting that in there, I've dropped it by about 0.75 volts. If I want to drop it by only about half that, then I need about half the resistance. Oof. Which would mean, if say that's the only resistor value that I had on hand, which it may be, because these are all, these things are salvaged from some old piece of equipment, then I need 4 of them in there. Do I want to mess with it? I don't know. Let's see what I've got. Well, no, those are 10 ohm. Yeah, those are 10 ohms. That's not help. Half an ohm. Got a bunch of those. These things aren't cheap. you know, start piling in, like how many half ohms would I need to get half of half? Got a sixth in there now, I'd really need a 12th. Oh, jeez. No, I can't. I can't. Five ohm. 500 ohm. Yeah, anyway, I don't know why I'm even looking through here. I know I don't have anything in here that I'd want to use. If I have anything I'd want to use, it's going to be in my collection of salvaged resistors. I mean, I've got 2 more 3rd ohm resistors. I could put 4 in. I have 2 more. I mean, sure, it'd be nice if I had something closer to the right value in the first place, rather than have to use. I mean, obviously these are salvaged, so it didn't cost me money that I can quantify, but opportunity cost and all. See what else is here. This one's 0.1 all by itself. Only 2 watts. What's that gonna do? Let's see. Let's say, okay, 0.1's. Anybody want to do the math for me? Nobody? Come on, no. Anyway, it's a 2 watt resistor. Let's say it's dropping, let's say it's dropping 0.4 volts. 4 times 0.4 is 0.16. 0.16 over 0.1 is 1.6. It's within the rating. It's a little close for comfort, but luckiest man alive, you are exactly correct. And these are not super difficult calculations. It's just my mind, my brain is weary. I'm not feeling up to the task, so I'm kind of winging it. That's the full story. Yeah, 0.15 and 0.22. These are both 2 watt. So I think among the 2 watt resistors here, the 0.1 would be better. It'll drop less voltage. I could put a couple of these different values in parallel, but Not sure I like the idea of trying to calculate that result. So I'm going to put it in the 0.2. I'm sorry, I'm going to put it in the 2 watt 0.1 ohm resistor. If it doesn't immediately start smoking, then that's one thing. I will measure the voltage drop across it to see how close to that 2 watt rating we are at. And if we're still comfortably below it, then that's my answer. Sound like a plan? I think so. Okay. So, luckiest man alive, where in Oz are you? I spent a little bit of time in your lovely country. I really did enjoy it. It's except for driving in Sydney. Driving in Sydney really sucks, especially if you're trying to turn right anywhere. For those of you who are, of course, Americans, most of you, turning right in Australia is supposedly, just similar to trying to turn left in the US. But anyway, wherever I was trying to get, and I think I was just trying to get to the rental car return to get rid of the damn car that I was driving. That it was on the right side of a street, and getting there took I think just accomplishing the right turn, which meant going around blocks and whatnot. It amounted to adding 15 minutes to the time. It's just so ridiculous. The fuck. I mean, I'm sure one gets used to it if one lives there. Driving elsewhere was just fine. I spent 3 or 4 weeks in Newcastle. In an apartment near downtown, and going out to the uni every day. Beautiful campus. At least I thought so. I guess it would help to let it warm up, didn't it? That's a snipper right there. That is solve this problem with cutters. Yeah, it's interesting. I was traveling around after spending the time in Newcastle and ran across some guy. And he's like, "Oh, where you?" And got into talking. He's like, Newcastle's a bit of an armpit, isn't it?" And I was like, "Well, I don't know. I mean, I thought it was kind of nice. I mean, being able to hike along the coast, uh, this giant coal seam exposed in the sea cliff, walking along to the state park or whatever it was, and finding like old campfires uh, composed of old, partially burned hunks of coal that people had just pulled out of the cliff to do to burn in their campfires. I thought that was pretty cool, really. Yeah, it's a pretty spot. Um, I mean, yeah, if you're not into coal, you go outside of town, um, and you drive by certain areas, and you just huff the sweet smell of coal gas. It's a little overpowering, but city itself's pretty nice. It's been more than a decade since I've been there. It was 2008, your spring of 2008 that I was there. That. Yeah, could do without the extra hunk of wire. Well, now I hear you, as a Kiwi, you have a lovely island I've never been. Um, well, you have a lovely pair over there of islands. I've heard wonderful. I traveled. I invited my mom, who then was only uh, 89. No, no, that's going on 20 years ago. My mom's 97 now. Anyway, invited my mom to come down and travel about around um, that part of Australia with me before I went home. But after I left, she went over to New Zealand and traveled a bit. Had great things to say about it. Everybody I know who goes to New Zealand has great things to say about it, of course. And that, as a geologist, it's just a kind of a playground. I would think, for me, it would be. But yeah, I think your impressions of people's impressions of Newcastle is probably about right. I mean, um, you could tell when I was there, they had put significant effort into sort of, uh, making downtown a nice place to be. Um, it's it's always tough an old downtown on the coast like that. You know, you get um, it's natural for as a city expands, right? You know, it can only expand in one direction, so downtown becomes less and less feasible for people to go to for errands and whatnot. Um, but city center was really pleasant. I just never forget like the what was it, City Hall. I would walk by City Hall, I think it was, and oh, those giant flying foxes um, perched in the trees, flying around at night. It's really something. Oof, come on. This is... As I said earlier, but if you might have heard or not, this is exactly the kind of work right now that I was trying to avoid by doing things in their proper order so that, I do the sort of bottom, or I guess really technically top of chassis since it is turned over. Anyway, doing the bottom work and then proceeding upward. And now that I've had to modify this whole dropping the voltage on the heater circuit thing, it's a pain in the butt. Pain in the butt. In the butt. In the butt. In the butt. Pain in the butt. It'll work for us. That's good to hear. Newcastle is a it's a nice place by the sea there. And I was like, you know, if I had to, I mean, even if I didn't have to, well, I could live in a place like this. Relatively chill vibe, and of course, the further up the coast you go, the chiller it gets. And the chill vibe you all have down there is endearing to those of us who appreciate that sort of thing. Yeah, Newcastle downtown, good restaurants, friendly people, all that good stuff. No complaints about the Newcastle of 2008. And it did seem to have a bit of an up and coming vibe to it as well. So, yeah, I can imagine it might be even better now. There's I suppose you could say a bit of a feeling of a hollowed out city center. Just speaking of the sort of struggle of maintaining an active city center as sprawl continues outside of the city and so on. Seemed like they were doing as well as could be expected with that, and good to hear that it's continuing effort that's borne fruit, as we would say. All right, that should do it. So I'll tell you a little story about driving in Australia. So, Mom and I, we drove up the coast a ways. That was fine. I had sort of planned out roughly where we would go and ended up going about half as far as we figured because while I had, looked at the actual mileages, because, it's easy for Americans to misjudge distances just by looking at a map. Your states are huge. It's a big country. And, but I figured mileages. What I hadn't really figured on, which was so different from here, is that the main highway is just like a 2-lane road that goes through every last town along the way. No interstate like we would have here. And so travel times were just way, way greater than I had counted on. And even though I thought I had been smart enough to account for mileage, but you know what? It wasn't that big a deal. We just didn't go as far, and we just, it's fine. But what I wanted to talk about, so we go north a ways, and then I think we got back down to around Newcastle, and we're gonna go down to Sydney, and decided to take a route through the mountains, and which is beautiful. Uh, that Great Dividing Range is really gorgeous. Oh, I remember we wanted to go up to the Blue Mountains National Park, which we did. And so we drove, sort of went inland from Newcastle and drove through the mountains to get there. And here's the thing, I'm driving along, I'm fine, but every single car that would sort of come over the short horizon, right, on this windy mountain road, I would just have an instant of panic because, oh my God, I'm going to have a head-on collision. It's on the wrong side of the road. Oh, no, okay, so, but just that instant panic of like every, just at some point had to, had to pull over, stop, just walk around, breathe. Okay, it's okay, it's all right. I just need a little break. So anyway, that was my rural mountain driving experience. I mean, I grew up driving in windy roads, and you learn to be alert for cars coming towards you that might be in your lane, and having to react quickly to deal with that. And yeah, that was a trip. All right, it's on. No smoke. No smoke. Let's see what we got in terms of voltage. First of all, all right, 6.2. That's good enough. Let me see what is actually being dropped across that resistor. Get in there. Check that out. All right, it's only careful. All right, 450 millivolts. Let's do the math. Give me a minute. I'll tell you my one Australian colleague told me a good Kiwi joke. E squared over R, right? Squared by one. Oh, yeah, that's damn. It's almost exactly 2 watts. Mm. Yeah, boy, that's rough. Probably be fine, huh? What do you think? Anyway, so here's my Kiwi joke. Um, don't stop me if you've heard this before. So they these scientists or researchers, what do they do? A study. They're trying to um, they have sort of this idea that the amount of time, that the sort of general uptightness of a culture can be represented by the amount of time that it takes uh, for people behind you to honk their horn after the light turns green. So, if the light turns green, you just stay there at the intersection. All over the world, people will honk. And, depending on how uptight people are in general, more relaxed places it'll take them longer to honk the horn. So they do, they go to New Zealand and do this experiment. And so, and light turns green, they're waiting. They're waiting. And they're just waiting, and after a little while, there's a tap on the window, and they roll down the window. It's like, "Are you okay?" That's how laid back people are in New Zealand, apparently, at least according to Australians, or on the laid back side themselves, at least have that reputation. Well, my friends, this is a bit of a result that I was not quite prepared for. In that my preliminary calculations, I indicated that I would be, at least under 2 watts, which is what this resistor is rated for. And in fact, I'm at almost exactly 2 watts. And it might be fine. It might be fine. But if my intention is to eventually pass this amplifier on to somebody else and represent it as a well-built and well-thought-out device, it would be rather irresponsible of me to use a 2-watt resistor in a place where the actual power dissipation is, even if ever so slightly, over 2 watts. Let's just because, well, okay, why? Because you just generally want to leave a margin for error. So, yeah, you just want to generally leave a margin for error. And this leaves me no margin for error. But then what else do I do? I don't have, I mean, I tell you what I do. I leave it in there for now, and I order some resistors that are appropriate. That's what I do. I go to my computer and I go to DigiKey. So, as this is a live stream about what goes on when one is building, this is a relatively common occurrence that I need to order something. And maybe it's not that I need to order something that I need right that minute. Maybe, if I've done this whole thing as I intend, then, I keep the parts, I've got the parts that I need on hand, or at least something close. And then, but as I run low on things, I order new ones. And so, in this case, I've got something that will do me in the pinch, as it were, but requires me to, but I need something better. So, DigiKey is where I go. I know people say they like Mouser. I think preference of one over the other is mainly which user interface do you prefer? The prices at Mouser are, but the cost of shipping at DigiKey is slightly lower. And so it tends to kind of come out in the wash, as we say. Let's see what I've got a comment in the chat. Yeah. I trying to remember. I didn't. I don't recall free shipping being a thing. What I generally do is get a cart that's big enough to, because shipping is sort of a flat fee of like $7 for me, and so obviously that means it doesn't make sense to order a 10-cent resistor and pay $7 in shipping. So I generally wait till I've got a cart that's got, I thought I had an active cart. Maybe it's, so I keep the cart going until I've got like $100 worth of stuff in it. And or maybe a case where I can pass the cost of shipping along to a customer for that I'm doing work for. What? This is not making sense. This is not right. Maybe I don't have an active cart. Last order was shipped January 10th. Yeah, okay. I guess I don't have an active cart. That's all right then. Yeah, 24 Australian dollars is a bit much. It's kind of them. They give you free shipping for orders over 60 Australian. I'm assuming it's Australian. I know your dollar is less than a US dollar technically, but not all that much. So, Anyway, so just if you're not familiar with DigiKey, I'm just looking for, let you, instead of scrolling down to find the value that I want, I've just put in zero point 0.1 to zero point 0.1 ohms, checked the in stock, and checked the exclude marketplace products. Marketplace is stuff like NTE. It's a third party. You pay, you have to pay a separate shipping. And if you can't find what you want, then sure, it's good that they give you the option of essentially getting the part from a third party. But in general, uh, given the choice, I don't want to choose a marketplace product. Good to chat with you, Luckiest Man Alive. Have a good one. Appreciate you dropping in very much. Cheers. It can be a bit sluggish, and I don't know how much of the sluggishness shouldn't really be my internet connection. My internet connections should be plenty good. I don't know. Sometimes I've done it. I it's not. Yeah, it's. I was gonna say, oh, it's more likely that my old computer, but I've through 10. Oh. So as you see, I get a bunch of results, and I typically then sort them ascending by price. Typically we'll go up here and say that I want it to show me more than just 25, but this friggin' sluggish interface gets me. Yeah, it's a kind of a sluggish interface. I'm not psyched about that. I heard my phone vibrating. My mom was calling, and so I will probably end this stream on the sooner side so I can give her a call back before it gets too late in Arkansas. What do we have here? We've got some ohmites, 5%, 10 watts, and sort of, I don't know, that sort is generally sort of less preferred than something like that. What's the price difference? These ohmites are wait, what? this is confusing. They've got two prices listed here. One's $1.44 a piece. The other's 23 cents a piece. I get to what? Um. One's through the marketplace. I think that's it. So these Yagios, 67 cents each. That's what I'll go with. 5% is fine for this. It's only 5 watt. It's probably fine too. It's at least fine for this particular purpose. And you know, this might be the thing that I ever use this particular thing for. So that being the case, 2 watts for 5 watt rating for a 2 watt dissipation. It's pretty good. I mean, see, what would I have to spend to get more with this style of resistor? Here's a 7 watt. That's also a Sandcast. Here's a 10 watt. Is that a Sandcast? Yeah. So this is typical. I'll look and see, like, okay, if I don't get the sort of cheapest thing that seems about what I want, if there's some aspect of it that, you know, I'd prefer something, in this case, a greater power rating. How much would I need to get? How much would I need to pay to get that in the style that I want? So here we go. Here's a Vishay, 7 watts. And that's $1.92 each. So, yeah. I mean, the pricing's, yeah, it's quite a bit more, isn't it? It's not just a little bit more to get 7 watt rating instead of 5, and 5 will do. So, man, so sluggish. What the hell? Yeah, I know, this is 7 watt, but I don't need, I've got 2 watts, and I only need, so 5 is plenty. I'm not complaining that it costs more, it's just, don't really need to spend it. It's twice the price. And I'm also thinking, I mean, you know, it's totally a valid point if I were thinking, okay, you know, yeah, but 7 watts give me greater flexibility in terms of using this for different purposes. But I don't foresee, I mean, I don't foresee it could happen, right? But this is likely the purpose that I will need these, for which I need these. Anyway, I can get 10 of them for $4, 33 cents. So that's what I'm going to do. Oh, and I'm here. I wanted to get some more 470 microfarad caps. Yeah, that's my thinking. TTVOR. Yeah, that's more work than saying true voice of reason. All right, capacitors. Passives. So you might suppose that what I would do, given there's so many different capacitors to choose from, if I thought these were the ones, and when I bought them, that I should just search for this uh, product number. But that's not the method. These are Nichicons. Nichicons aren't generally my first choice. Nichicons are fine, but they're made in China. I prefer the made in Japan that you can get from Rubicon. And so go in here, type in 470 and 470. Again, if Nichicon's got the right thing for the right price, that's fine. I generally go over here to the manufacturer and I limit my choices to the ones that I'm, generally prefer and I'm more familiar with. So, typically I'll check Elna. Not sure what's going on with Elna these days, but, Nichicon, Panasonic. Not sure what the difference between Panasonic and Panasonic Industry is. Of course, I generally preferred Rubicon. Is that it for me? I mean, it's not that other makes are necessarily bad. It's just, so for example, these days I'm most familiar with Rubicon's product line, and that's a thing. Voltage rating. So these are sort of my do-it-all capacitors. So I'm gonna generally want them to be greater than 50 volts. The ones I've got are 63 volt rated. So I'm gonna accept anything up to 100 volt. And generally you pay more for a higher voltage rating. So there's that. I'm gonna go to want in stock. I want to exclude marketplace products. And just quickly see what's that going to leave me. It's going to be 231 results. All right, what am I forgetting that I want to make sure I could check, like, I don't want things that are not for new designs. I don't want things that are obsolete. I don't care. Where that becomes important is if you are looking to develop a bill of materials that you're going to put in production, right? So you'd want something that is an active product. But for me, that's not a consideration, really. Oh yeah, definitely. Yeah, I generally want to be picky about my lifetime at temperature, so that's really going to cut it down. I'm going to want stuff Oh, I'll go for 8,000 hours at 105C and up. Um, because I want to be able to use these in hot situations like in tube amps and yeah. So that gets me down to 54 results currently. Oh, so sluggish. Okay, again, I'm going to sort by price. Oh, and I should put in a price by quantity here because it's potentially showing me some stuff that I might not really be able to get. I don't know. I'm gonna put in 10 there. That's how much that's how many I bought last time. And that'll sort of exclude the things where you got to buy 1,000 of them to from the, or at least shove them to the bottom of the list. All right, so here we go. There's a Nichicon. What were these? These were UHE. So there's the UHE 50 volt, UPW 63 volt. Here we go. There's a Rubicon YXJ. It's probably okay. I do generally prefer the ZLH. It's only 50 volts. Let's see, 80 cents each. Let's see, how much more do I have to pay to get higher voltage rating? And YXF, I don't think that's what I want. ZLJ. There we go. So 63 volt ZLH Rubicon is 92 cents each for 10. So it'll be $9.20 to get 10 of those. And oh, don't you do it. Where is the... I'm trying to figure out what it's telling me over here. Like, that's not even... Oh, ripple current at high frequency. I wonder why that's, like, all the way over there. Oh, shit. It did. It just, took me back. Yeah, it's a little aggravating, this interface. So it might, if this keeps up being this slow all the time, it might drive me to Mauser. Alright, there's that ZLH that I was looking at. There's a bunch more specs tabled here. I know that I like ZLHs. Those are sort of, check all the boxes in terms of their intended use and so on. And so that's what I'm going to go with. I'm going to pay a little extra, a little more than I could for some others. The Nichicon at the top of the list would have been cheaper. This is one I know is a good one, and 10,000 hours at 105C, made in Japan. Okay. And if I wanted to check out, I would go to View Cart and see my total right now is 2149. It's got an asterisk. Products in your cart will require an additional day of processing. Shows me an estimated tariff for those Yagios is a whole friggin' $1. Oof. Yeah, but those, yeah. Hey, Bob. Cool to see you here. Yeah, I don't care about loose reel or tape. Like I said, I could have looked up all those specs on this, but I've sort of sifted through their product line, and I know the ZLHs have good specs, so that's what I generally go with if they're available. Anyway, that's where I'd have to pay to check out. I'm not super psyched about having to pay a whole extra $1 for just on top of $4.33 for these resistors. Thanks, Donnie. Anyway, I'm not going to buy now. I don't need to buy now, but get the idea. And I think, maybe I'll pick this up again later. But my mother called, and she's 97, so I don't want to leave her waiting. And there's a 2-hour time difference, so good to talk to you. Good to see you all. Oh, save the cart. It saves. I think it saves automatically. Do I need to save it? No, it saves automatically. I could name it, but I don't have anything particular to name it. That would be the way to save it. Yeah, you're right. All right. I will name this one routine parts order for spring. exclamation point. No exclamation point? There we go. Yeah, I mean, generally saving them isn't required. They'll be saved automatically. They may not always come up. Um, generally, even if I closed that window and I didn't close it, I just minimized it. But the next time I go back to DigiKey, it would probably have that cart. I would probably go directly to that cart being active. Maybe not, and if not, I would just have to go to open my carts and select that one and resume it. You will maybe have seen that I have 2 old carts in there that I never bought, I never ordered. Anyway, all right, gentlemen, perhaps ladies, but probably not. I'm going to sign off. It's been a pleasure. Thank you for joining me. And I might start again later. And so watch out for that. Good chatting with you all. Yeah, those carts in there were like 2 years old. Thank you. Cheers, y'all.